Question 17. Rodri is investigating the population growth of rabbits in an enclosure, and he counted the number of rabbits at the start of month 0 and the start of month 2. The population of rabbits is increasing exponentially. Now this is important because the fact that it says exponentially means that the variable that we are changing needs to be in the power of our equation. So we need to form an equation, and we're going to find the population, so let's call that P, and that's going to be equal to K, which is a constant, multiplied by some form of rate of change, which we don't know, but we know that the power is going to be T, because that's the variable that we're changing here. We're changing the month at which we measure the population, and that's time, so we're going to put that in the power of our equation. Now K is a constant, and that's the starting population, and that's always the case with these types of exponential equations. So K is our constant, and the starting population, well, that's going to be 100. So actually we can replace K with 100 straight away. R is our rate of change. So this is the amount of increase in the rabbit population that we see each month. And we know it's going to be bigger than 1 because it's saying that the population is increasing. So it has to be bigger than 1 to make that population increase. So we've started with an equation that has P, the population, equal to 100, our starting point, multiplied by some sort of rate of change to the power of T. And we need to use this to find out how many rabbits there will be at the start of month 5. Now we know that when T equals 2, which is month 2, Rodri found that the population was equal to 200 rabbits. So we need to substitute that into our equation. Instead of writing P equals 100 RT, we're going to write 200 equals 100 times R to the power of 2, where we just swap T for the 2 and P for the 100 in our equation. Now if we solve this by dividing by 100 on both sides, 200 divided by 100 is 2, and 100 divided by 100 is 1, so that's just left us with R squared. And then if we square root both sides, we find that the square root of 2 is equal to R, our rate of change, which is around about 1.4. So that's about 40% increase in population per month of this rabbit enclosure that Rodri has. So let's just adjust our equation. It's now become P equals 100 multiplied by the square root of 2 to the power of T. So we could use this to find out the population at any time, but it's asking us for month 5, so we're going to substitute T with 5, and we're going to calculate 100 multiplied by square root to the power of 5, and that gives us 565 point something, just check, 565.68, 685, and we're going to round that to give us 566 rabbits at the end, or the start of month 5, sorry. So the population is 566 at the start of month 5.